Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSS sheet, and in this we were doing linked list topic and pattern was reversal pattern. Today we'll do the next question, which is maximum twin sum of a linked list. Why we are doing this problem just next to the palindrome linked list? Because the idea and logic will be similar to the palindrome linked list. So let's read the problem statement. It says we'll be given a linked list and we have to return the maximum twin sum, where twin means first and last node summation. Second twin means second node and second last summation. So if you see here, 5 plus 1, total summation 6. 2 plus 3, total summation 5. And in this case only 1. So out of all twin summations, what is a maximum sum? 6. So this is what expected answer. So if we see here the constraint, it says the number of nodes will be minimum 2 and it can go till 10 power 5. It means n squared solution will not work because 10 power 5 multiplied by 10 power 5 becomes 10 power 10, and you know beyond 10 power 9 or 5 into 10 power 8, beyond that the code might give us TLE, and for sure at 10 power 10 so it will give us TLE. How I said that? Because we have discussed everything in detail in our time and space complexity video. If you have not watched it yet, then definitely I'll recommend you, and I'll add the link somewhere here, you can check it out. But anyhow, in the linked list you know that the code will rarely go till 10 power 10, means n square, because mostly we'll be able to solve the problem in just linear solution. So let's see how we can solve this problem here, as we have to give the twin sum. So if it was not linked list, if it was array, then definitely by using two pointer, left pointer and right pointer, we could have done the summation, and in some max variable we would have updated it. Can I say that? Next time left plus plus and right minus minus. Now we'll check for the second and second last node. Again summation 5, but 6 is still greater than 5, so we'll not update the maximum sum. Next time again left plus plus, right minus minus. Again the maximum summation 1, still greater than 6. So at the end this is what we will return. But in the array case, right minus minus is so possible. But in linked list case it is not possible. Why? Because linked list is in towards right direction, means every node is having the addresses of right nodes. If you want to track back, it is very important to reverse the half linked list, and that's what we did, if you remember, in the palindrome linked list problem. But that is the optimized approach. If you don't know how to reverse it, how you could have solved it? Simply run, means iterate in the linked list and save it in the array 5 2 1 3 1. And the next approach will be the two pointer. Initialize your left pointer from 0 and right pointer from the right side. Okay, and now while your left is less than right, just keep doing what? Array or list of left plus array of right, and just save in some max variable by checking whatever is maximum, means the max is maximum or this current is maximum, correct? And after coming outside, you just need to return that max answer. Okay, I hope you understood this. We will just do left plus plus and we'll just do right minus minus, and we'll keep doing this left plus plus and right minus minus. Let's see the cleaner code in the editor. So here is the code what we discussed. Create the list, run in the entire linked list, one by one read the values and put in the list. Now initialize a two pointer I and j, and answer will be nothing but your max answer. While your I is less than j, just keep like reading the values from list, means I first value and j last value. Whatever is maximum, just keep storing in the answer variable and do I plus plus and j minus minus. Once done, after coming outside, just return the answer. So what is the time complexity in this case? First O of n to run through the entire linked list and save all the values in your lists. So O of n time complexity and O of n space also, because you have used that extra list here. Another O of n by 2, yes, n by 2, which is linear only, but exactly if we talk, it will be O of n by 2, because in every iteration I and j both are moving with the same speed, correct? So we are running until I and j are like I is less than j, means for sure at a meeting point, means in the middle they will cross each other and you will stop at that time. So what is the number of iterations you have run? O of n by 2. So total O of n plus O of n by 2 means 3n by 2, although it is linear, but this is brute force approach. Can we do this without using extra space? Yes, we can, because I hope you are following the pattern wise playlist and we already have learned how to reverse the linked list. Okay, and also the previous problem, which is palindrome linked list. If you have done that, this will be very easy and you can solve this question on your own. So the logic was very simple. You have to reverse the second half. To reverse the second half, it is very important to reach that middle of the node. And to reach the middle of the node, whatever different types of patterns we learned. First, the basic operations means deletion, insertion, update and all, that though is not required here. Second, we have learnt is fast and slow pointer. Fast and slow pointer approach help us to calculate, like to find the middle of the linked list or to check if there is any cycle or not. That's it. Like in most of the cases, this is what the expectation will be. Third, we have learned about reverse technique or reversal technique. Okay. So in this case, as you can see, we have to reverse the second half. So reversal technique will be used. But to reverse the second half, it is important to reach the middle node. Although you can reach the middle node also. But how? First you will calculate the length of the linked list and then in the second iteration you will reach to that middle node. But again, you have done this in 2 iterations, right? But the logic means optimize approach wants we have to solve this in single iteration. So to find that, fast and slow pointer approach will help you. Okay. So what we will do, we will start our slow pointer and fast pointer from this case. Now slow will move to next and fast will be here. Now in the next iteration, slow will be here and fast will be here. And as the fast dot next is null, so you will stop. So where is slow pointing? Middle. And now rest half we have to reverse it. Means this is how. Now again you will start your slow pointer or you can say left pointer and right pointer from here. You will do the summation. Next time left dot next and right dot next. So this time you are coming back because you have reversed the half, right? So now your left will be here and right will be here. Again you will do the summation, save in the maximum variable. Again you will do left dot next, right dot next. But until when? See, when we have reversed this half now, if you know how to reverse, the node where you start, you connect this to previous pointer, means null. So 3 is pointing to null, correct? So basically this left, right, next time left, right, next time left will point to 1 but right will point to null. Means right will point to null. So in the while case, like we have to keep doing the summation, twin summation until the right becomes null. But why only right becomes null? Because the length was odd. And because the length was odd until this is your mid length, so definitely the left half length will be greater than the right half. So for sure right will become null first. Now even if it is about, like suppose even length, okay, so left, right, left, right, left, right, and in the next case left will be 3 and right will be null. But why left will be 3? Because you have reversed this much node. Remember, till mid you have not reversed. So 1 is still connected to 3. So 1 can still go to 3. Okay. So in this case also when right hits null, you will stop. So now because this code we have already discussed in the previous one, so I would really like to show you the solution directly. So here is the code what we have discussed. Slow and fast pointer will start and this much while loop of code will help us to reach to that middle of the linked list. Once we reach where slow is pointing, that will be our middle node. So from that slow point, we have to start reverting. It means now from slow pointer we have to revert. So until the slow again becomes null, we have to revert. So this is the revert logic, correct? And I hope you all know that. Now once done, you know कि wherever previous is pointing to, if you reversed, right? So current comes here at null, remember? And previous points to the last node. So can I say this is what the head is? So can I say this will be our right pointer and the head again will be our left pointer? Correct? And what we said, we keep on adding until the right becomes null. So can I say we keep on adding until our previous becomes null? Yes. So that's what we did. Answer will be our max answer until our previous becomes null. In our max answer, we'll just keep on adding head value and previous value. Head value means left pointer, previous means right pointer. Now we'll again do head dot next and previous dot next, because head is moving towards right direction and previous is moving towards left direction. Once done, whatever is the calculated maximum answer we will return. Now let's see what is the time and space complexity in this case. First, so you have exactly used O of n by 2. Why? Because fast is moving with double speed, correct? So O of n by 2 time complexity to calculate the middle node. Once done, again further O of n by 2 to revert it. Why? Because you are reverting the second half linked list. So O of n by 2 plus O of n by 2, exactly O of n? Yes. And now in this case, because we have to start our 2 pointer to check what? Twin sums. So further O of n by 2. So in total O of 3n by 2. There also in the brute force and here also in the optimized. But what is the difference? The difference is in the space complexity. Because in the list solution, we have taken extra list which takes extra space complexity. But in this code, as you can see, we have played only with pointers. So space will be constant. And that is the reason it is optimized code. But time wise, both will be similar. So let's run the code and let's try to submit this. So as you can see, it has been submitted. So this was your Java code, and with the similar logic, here is your C++ code and here is your Python code. So I hope you understood the brute force and the optimized approach, which is the space optimized approach, and how the fast and slow pointer along with reversal pattern has helped us to solve this problem. Okay, so I hope you understood. If yes, then another question you can mark as done. And also please do let me know in the comment section if you understood and you have solved on your own. That's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. Till then, keep learning, take care of yourself and your family.